Hey, what's up? It's Mr. Stewart here coming at you with another one-take video. Today we're talking about balancing reactions, which is probably the most important skill that you would learn in the ninth grade science class. This is a skill that you're going to use in chemistry. It's going to be your bread and butter. Everything goes back to this skill. And it comes out of what's called the conservation of matter, which says that matter can't be made or destroyed. You can't make or destroy atoms. So whatever atoms you have at the end of a reaction need to be the same as the atoms that you started with in a reaction. So there's a couple of other learning targets that are kind of tied up into this. But what you're going to see is that the mass should never change because you should have the same atoms after that you have before. So unless atoms are going into your reaction or coming out of your reaction, maybe it's giving off a gas, maybe it's taking in atoms from the air into your substance. Unless one of those things is happening where atoms are coming in or leaving your system, your mass needs to stay the same, which means you should have the same atoms before and after. Long story short, your reactants, that's the elements that come in, your atoms that go in to reaction, and your products need to have an equal number of each atom. And so the way we represent our reactions is through what is called chemical equations, where you have a list of the elements and their chemical formulas, and you have a representation before and after, and you have the same number of atoms on each side. So I'll give you a very simple example using some of the things that I did in class, if you have me in class. So one of the things I started with was what's called a Hofmann Apparatus, two little tubes, and you connect it to a battery, and it splits the water molecule into hydrogen and oxygen gas. So we have H2O, that's what we start with, that's our reactant, and it produces H2 and O2. So I run a battery through it, and it splits the water molecule into hydrogen gas, which is H2, and oxygen gas, which is O2. And so the very first step behind all this, I like to draw this line down the middle. You don't have to do that if you don't want to, but I like to do this. And then draw a diagram down below. I'm going to shrink my screen a little bit. You're going to see, oh, I can't shrink it. Get smaller. Get smaller. I'm going to move myself off the screen a little bit. So I'm going to draw a diagram of each one. So H2O, if I interpret that correctly, would be HHO, and H2 would be HH, and O2 would be OO. So if I had one of each, that's what I would have. Now the problem is, on this side, I've got one O, and on this side, I've got two O's. So it looks like I've made an oxygen atom out of nowhere. And we know from the conservation of mass that that can't happen. So what we need to do is to balance this reaction by adding more until it balances. And I can only add atoms in the packages that they come in nature, which are listed up here. So I can't, even though I need just one O atom on the reactants side, here we are at the one take again, things I would edit out, put that on the list. Even though I just need the O from that material there, from H2O, I can't get that. It doesn't come in that package. It comes with two H's attached to it, whether I want it to or not. I don't get to pick and choose which part of the chemical I use. I have to use the whole chemical, which is H2O. I can't just pick up an O. I have to take the whole thing, which is great because now I've solved my oxygen problem. Now I've got 2 to 2. So my oxygens are equal, but my hydrogens, H's, are not. I need more on the products side, H, H. And now it's balanced. I've got 4 hydrogen to 4 hydrogen, 2 oxygen, everything's equal, we're good to go. The last step is to count each chemical and put a coefficient next to it. So this is 1, 2 copies of H2O, so that's 2 there. 1, 2 copies of H2, so there's 2 there. 1 copy of O2, there's a 1 there. 2, 2, 1 is my answer. Which is why when I did this experiment in class, I had those 2 tubes. One side had twice as much gas as the other side did, because the hydrogen, there is twice as much of it in this reaction. So this is how to balance equations. I'm going to do a few more examples for you. So how about this one? Fe2, Fe plus O2, those are my reactants, produces Fe2O3. This is an experiment we did in class. We took steel wool, which is iron, and we burned it over a Bunsen burner, which reacts with the oxygen atoms in the air, which are O2. And that made some blue kind of like crust on the outside of our steel wool, which is Fe2O3. So that when we added it to the scale, it actually weighed a little bit more because it has these extra iron atoms on it that weren't there before, when we weighed it before. So again, start by drawing 1, 1, 1, seeing if it balances on its own. Spoiler alert, this one does not. So 1 Fe, which would be like that, 1 O2 would be O, O, 2 O's, and then 1 Fe2O3 would be Fe, Fe. Remember, Fe, iron, is a 2-letter element symbol because the E is lowercase, and then O, O, O. So right away we see we have 1 iron on the left and 2 on the right. So we have, and we also have 2 oxygen on our reactants side, reactants, products, and then 3 on our product side. So we have lots of balancing to work out. So we can fix our iron right away because that one's easy to fix. The irons come alone. Fe is by itself. And then we need another O. Now it would be nice if I could just take the piece of the molecule that I want and just add 1 O. But I can't do that. Nature doesn't give us single oxygen atoms. It gives us O2. So I need to add the whole molecule, O2, which unfortunately upsets our balance again. And again, it would be great to just take the part that I want. Just put another O there. I can't. I have to copy and paste the whole thing, O, including all the irons that I may or may not want. Nature decides what the chemical formulas are. All we can do is choose how much of them we have. So now we have 2, 2, and 2, and we're still not balanced. We need more oxygens over here. So we have 3 oxygen on our reactants side, 3 O2s, and our oxygens are balanced, 6 to 6 on the O's. The irons are not, so we need to add more iron on the reactants side, Fe, Fe, and now we've got 4 to 4. So now we're balanced. 1, 1, 2, 3, 4. 1, 2, 3. 1, 2, 4, 3, 2 is your answer to this one. Now it's balanced. Let's try another one. Another experiment we did in class was we took copper chloride, CuCl2, that was like blue liquid, and we added aluminum foil, Al, to it, and it produced a lot of heat. So I'll put that here, energy. We'll come back to that. And, well, we'll actually come back to that another day. AlCl3, it's aluminum chloride. We couldn't see that. It was in the water. And Cu, copper, which is kind of gunky, pink-looking, kind of like pond scum looking stuff. But it's copper that's come out of the water. So it was blue and then it became clear because the copper and the aluminum traded places. The aluminum was in a solid form and the copper was dissolved in the water. And then the copper came out of the water and the aluminum went into it to dissolve in the water. And that's why we ended up with copper gunk and a clear liquid. So this is, I was going to draw 1, 1, 1, 1. it'd be CuClCl, Al, AlClClCl, and Cu. That's 1, 1, 1, 1. It does not balance currently. So we have 3 chlorine over here on the product side, and we have 2 on the reactant side, so we need more chlorine over here. And again, we have to add the whole molecule, whether we want to or not. So we need another chlorine on this side now to balance that off. And again, it comes with more stuff. And then we need more chlorine over here to balance that off. Okay, now my chlorines are fixed. I have 6 to 6. We're okay. But my copper and my aluminum are all still messed up. So I need more aluminum on the reactant side and then more copper on the product side. Now we're set. 3, 1, 2, 3. 2, 1, 2. 2, 1, 2. 3, 1, 2, 3. And so when we balance reactions, all we get to do is add more to our coefficient. We can only change how many copies of the formula we have. We cannot change what that formula is. That's set by nature. Nature decides what things react and what things don't. And so all we can do is copy and paste the whole formula until it equals out. And so when you're done, you just fill in those coefficients. The answer would be 3, 2, 2, 3 for this problem. There's a practice assignment up in Schoology. You can take as many times as you want. I will tell you this, it is worth double what the rest of them are because 1, it's more work. It's kind of long. These problems take a minute. And 2, it's the most important thing we will learn in the chemistry half of our class this year. So as always, this is Mr. Stewart. Keep learning no matter what.